I hope you all had a great morning and that you're ready to get started learning a little bit about the future of C# and what's coming in the next versions of C#. So over the past almost 2 decades, C# has evolved into a really interesting programming language. We've seen the C# team and the F# and the VB teams taking in inspiration from other programming languages. Like we've seen them take inspiration from Kotlin and Swift and Java and C++ and a whole lot of other different languages. And a few of these features are making it into C# and has over the years. Like generics, for instance, came out of the research team at Microsoft. And we get pattern matching that comes from other interesting programming languages as well. And a lot of these features are what we're going to cover in this session. We'll talk about C# 8 and what's coming beyond that, and a little bit around when we can expect to get this into Visual Studio. So is everyone in here a C# developer? Excellent. Excellent. So then I don't have to teach you the basics of C#. That's good. So before we get into what's new in C#, I just want to introduce myself. I'm Filip Ekberg. I'm a Microsoft MVP. It doesn't mean that I'm employed by Microsoft. It just means that I kind of go around to conferences and talk about the news in C# and talk about news in Visual Studio and things around the language and things I like about Microsoft. So I'm kind of working for free as a marketing person. Joking aside, you can follow me on Twitter. Just ping me if you have any questions during, after. Probably couldn't do it before the talk, but you can ping me on Twitter if you have any questions. And I've got a free book on C# as well that you can grab if you just check out my Twitter. And if you ever come to Sweden, I'll take you out for a dive as well, because I love diving. All right, so in C#, we have all these amazing features. Over the years, we've had introductions of things like generics. We have async and await, things that make the language a lot easier for us to work with. It also makes it easier for us to write code that breaks. So we need to be very cautious about the features that we introduce in our programming language, and especially how we use them. In the early days of C#, C# came out almost 2 decades ago. I think it's 18 years old. Now, a lot happens in 18 years. The first version of C# had what you needed, and the reason they released C# is to compete with Java. So we got all the normal things. It runs in a runtime, you got the if and else and a switch and stuff. But then you want more things in the language to make it easier for you to write better applications. So they introduced things like generics, which is kind of a groundbreaking feature in the language. Changes the way that we write applications, right? The same goes for async and await. It changes the way that we work with resources, no matter if it's web resources or a database call or reading files from the disk. And even if this was a feature released in C# 5, we still see improvements in the coming versions of C#. And I'll show you a few of the features that they're adding in C#, probably 10, but we'll get into those features later on. But what they're making changes in async and await means that we need to just learn a little bit more about how this affects our applications and how to get accustomed to these features to write better applications. We all have favorite features in the language and stories around things that change the way that we write the applications. I have an interesting thing happening to me when C# 3 came out. They introduced the implicitly typed local variable, also known as the var keyword. I remember having a conversation with a coworker. He tried to convince me that when you use the var keyword, you're not writing dynamic code. So I had to decompile the application just to prove him wrong, or just to educate ourselves, because I wasn't really understanding all of these features either. So one of the really good ways to learn these new features is to introduce them in the language, decompile the application, and look at the IL and see how it affects your application. That's how I've learned a lot around how C# works internally. And of course, dynamic came later on in C# 4, and then later on in C# 6 and so forth. We got even more things added to the language. But I won't bother you going into all the features released in C# 1 through 7.3. An interesting fact, though, is that with 7 and 7.1, 2, and 3, they did something that they haven't done before. So in the first 15 or 16 years of the C# language, they'd never done a point release of the language. So think about that for a second. How come that they can now do point releases, which means that they can just, with a small update of Visual Studio, they can increase or incrementally change the compiler. This is due to the fact that of this project, the Roslyn project. Roslyn is an effort inside Microsoft to rewrite the C# and VB compilers. It's also known as the .NET compiler platform. This has been around for a while as well, so I imagine a few of you already know about this. But what you might not know is that they're working on this as an open source project, and they have for a few years as well. This doesn't mean that they work with this as an open source project like Apple does their open source. Apple does internal development and then release the source somewhere, and you can just download that. Microsoft work as a true open source project with the Roslyn project, which means that they take contributions from the community. They have discussions on GitHub about language features. So this here is a page for language feature status. It's things that they want to introduce in the language. For instance, we have something called default interface methods at the bottom here. I'll get into that a little bit later on. But we have a ton of more features here that they talk about they want to add into the language. So what happens is that they might not have people internally that have capacity to build these things, or they might not just have the time right now. So the community can help out to build these features as well. And that's a great addition as well. So this means that we can help evolve C# as a programming language. And you'll notice here that it's my avatar up here. So I've made this huge contribution to the .NET compiler platform. I, in fact, went in here and fixed a spelling mistake. So that's my great contribution to this project. All joking aside, though, anyone can go in here and help out, not only with spelling mistakes, but help out with things like introducing features into the language. A few of the features that I'm going to show you here today is things that have been introduced by the community, or the community have been very involved in making sure that this adapts to what a C# developer expects. We also have another page, which is or another repository called the C# language repository. This is kind of the specification of things they want to get into the language. So Roslyn is the compiler part of things. This is the language, I guess, the specification of what's going into the language sometimes. So they have all of these champions or epics or whatever you want to call them. They have things here like, how do we make nullables work better in the language? So they have a champion for null reference types, which I'll also show you later on. And they have all of these different things that they want to add to the language, and people can go on and discuss these different features. And they can even say that I want to improve this, I want to build this, and I want to help out, contribute to this. So if you have really sharp eyes or maybe binoculars on, because I made the font size really small here, but at the top here it says that this C# 8 candidate is due to be released somewhere around 2080. I don't imagine I'll be doing C# by then. So whoever set this this end date, yeah, I don't know what they were thinking. But anyways, it's probably just a placeholder, right? So they'll update that, and I'll talk a little bit more soon about when this is coming into Visual Studio. But it's based on all the things that we have listed here. It's about 7% complete, right? So based on that, if we know that C# 8 is going to be released soon, some of the features might not make it into the language, even though we talk about them. But just because they're not making it into this version of C# doesn't mean that they're not getting into C# 8.1 or 8.2 or 9 or 10 or X or whatever you want to call the next version. So when is C# 8 going to be released? Well, I had hopes for this to be released with Visual Studio 2019, which is due to be released on April 2nd. They have this launch event that anyone can participate in online, and they're going to release Visual Studio 2019. Now, I just read an announcement, I think they released yesterday, where they said, well, we're not going to release C# 8 with Visual Studio 2019. We're going to wait until we feel comfortable with both C# 8 and .NET Core 3, and then package this in Visual Studio 2019 when it's available, when it's ready for you to work with. But that doesn't mean that you can't use the features in Visual Studio 2019. That's totally confusing. So they will actually ship C# 8 as well as .NET Core 3.0 with Visual Studio 2019, but you have to enable the preview of the compiler as well as the SDK that you're working with. So you'll get gradual updates with Visual Studio where they update the compilers, but as long as you don't enable any preview features, the next version of Visual Studio will still be C# 7.3. So C# 8 and .NET Core 3.0 is going to be released sometime this year, and a few of the features that we're going to get into the language is some of these C# 8 features. And I'll go through a few of these features in Visual Studio. Now, I did something really stupid. I updated Visual Studio a few days ago, and everything broke. So a few of the features, we'll just have to imagine that they work. Most of them still work, but you know. So this here is Visual Studio 2019. It's the release candidate version of Visual Studio 2019. But before we can get into exactly the features that are getting into C# 8, I just want to quickly run through two features added in C# 7. Just in case someone doesn't know them, it gets really hard following along, because a lot of the bigger improvements in C# 8 is due to things like tuples and pattern matching. We could probably spend an hour talking about just tuple and pattern matching, but that's not the point. So in C#7, they introduced this thing called tuples. Now, tuples have been around for a long time, but in kind of a different way. Now it's a first-class citizen in the language, which means that in this case here, I can say, well, this method call here returns two things. I could even say that it returns a lot of things, but I don't know why you want to do that. You could just introduce a class, it gets more readable, right? But you could do this if you want to. This creates a tuple with multiple different fields. And what's interesting with these tuples, I'm not going to do that because it breaks everything else, is that I can create this tuple here of values that will be mapped into the tuple that's returned. So 100 will be mapped into x and 200 will be mapped into y. Kind of obvious, right? And then when we call this method, I can say var point is equal to getPoint. Side note, the reason I updated Visual Studio was because when I started coding some of the demos, Visual Studio would deadlock. So I just had to update just to make sure that I could still live code. Right, so when I call var point here is equal to getPoint, what would you expect that I get out of this thing here? Well, if we say point dot, we in fact get a way for us to use x and y. So this here is a really nice addition. Previously, when using tuples, you would get item 1, item 2, and so forth. So that's a really nice addition. But this brings us into something that they call deconstruction. Now, this is another way just to do the same thing. Instead of doing var point here, you can do int x and int y inside this tuple syntax here, and that would just map the values. But what would you imagine happens if I change these around? Actually, this is the wrong way around. So what would you imagine happening now? So I'm returning x and y from my getPoint. I'm expecting y and x down here at the bottom. It's actually not mapping this by naming. It's mapping it by position. It's called position matching. So y here will in fact get the x value. So this here just shows that it can be a little bit fragile, so don't do this. It would probably be better off just saying var here. That would make more sense. So this brings us into deconstruction. Deconstruction is a way for us to take the tuple and create some other tuple that looks similar. But in this case here, I say, well, I have this tuple here of x1 and y1. In fact, this creates two local fields instead of putting this in a new tuple variable. So I can simply use x1 and y1 here, but it's still tuple syntax. And then we can make this in different ways. We can say that we have this simplified version of saying, well, I have a variable or I have two variables, x2 and y2, and just map those values correctly. So that's tuples. It's super simple, really. But still, we need to understand tuples and just how they work and that they are existing in the language. Now, another thing added to C#7 is pattern matching. Has anyone done any other programming than C#, like Kotlin or Swift? No one? Perfect. Wait a minute, one or two. So that's perfect, because that means that pattern matching might be new to you. Now, pattern matching is a way for us to say, well, I have this class, or I have this thing, and I want to apply patterns to understand which thing it is. But I don't want to be too explicit about that. Now, of course, we've been able to do this in the past. If I want to have this shape here, and I want to check, well, is this shape a triangle? Is it a rectangle? And then I want to cast this to something else. We could, of course, do shape.getType, and then type off, so forth, right? So this here becomes really verbose, and then you need to be typecasting if you want to use that particular rectangle and so forth. You get the idea, right? So how do we do this better? Well, we introduce pattern matching. In this case, we use this switch syntax to say, based on the shape that I have here, in the case of it being a triangle, capture this as a local variable of t, and then I can use t inside this context. So that's neat. What I can also do, something that they introduced earlier in C# is a way for us to do, exception filters, where you can say if this exception is a HTTP exception and the status code is 400 or something like that. There's a syntax for doing this. It's the when keyword. We can apply that here as well. So I can say, in case of this being a triangle, capture t, and when t, and we have two sides, we have a, is not equal to t.b, then run this context here. And then I can have another case down here which says where triangle, where it's a triangle, capture that as t, and when it's something else, right? So you could have multiple different cases here using pattern matching. This is really nice, because this means that I don't have to do any typecasting. I can use this syntax to just ensure that this is a little bit better. But we've been able to do this for quite some time now. This has been available since C#7, which is a while. So how has this improved in C#8? The reason that we talk about this is because the next things get really confusing if you don't know anything about pattern matching. So in C#8, they introduced something they call recursive patterns. Now, recursive patterns is, let's think of it as a way for us to apply multiple different patterns, and we can match on certain different things. So in our case, we said when this is a triangle, I can match to a few different conditions, right? Now I want to say that, well, in case of, I want different patterns to say, well, if it has these kinds of attributes or these kinds of traits or these property values, then I want to get into the context. So just to show you an example of this, I'm creating a shape here, just a triangle, super simple. Then I call a method called explainShape, which is going to use a few different things. First of all, it's introducing a new way of us to do pattern matching. It's introducing something called switch expressions. So you'll notice here that I have this weird syntax or this weird expression where I'm saying, well, I want to return something, which in this case is going to be a string. I'm going to return a string based off what the shape is. And then each case inside this switch is in fact going to be this expression here, right? So this is like an expression-bodied member, pretty much. So on the left-hand side, we have a pattern. This is the same that we saw earlier. So I can say when it's a triangle, then do this, only when A is not equal to B. And when that's the case, return this string. Super simple. Then we have other ways of us to apply patterns, which is a new way for doing this in C#8. We have something called positional patterns. So how does that work? In this case here, I'm saying when there's a rectangle and when these things have these different values. But what are those things? So this here is in fact a tuple. But what does that mean in this case here? Well, if we go into the rectangle, we've introduced something called a deconstruct. A deconstruct is a way for us to get a representation of the object. So I'm saying here that the first thing that you get out of the deconstruct, which is simply just a way for us to get a tuple out of this, the first one is width, then it's a height, then it's a point. So now if we go back and look at our switch expression, in fact what's happening here is it's saying when the width is 0 for the rectangle and when the height is 0 and I don't care about the point, then run this thing here. Does that make sense? That's pretty cool. So we can use this in different ways as well, and I'll get into a permutation of this, where it makes a lot more sense in just a little bit. But let's stick to the shapes and the rectangles now. So this here uses or leverages the deconstruction. So I could change these to different things here, and I could even capture the point like this, and then I can use that point here as well. Right, so you can do all kinds of crazy things. And then we have something called a property pattern. So in case I don't have the deconstruct, in case this here, the one at the top here is a little bit too verbose for me, saying when I'm looking for values, I don't want to use when for all of them. So I can use this property pattern instead, where I say just match these two rectangles where the width is 100. And then this returns this string here as well. So this is multiple different ways for us to match on different types of patterns of objects and their different traits. And then, of course, we can have multiple patterns in here, and they're all matched in order. So the one at the top will be matched first. So we have this example here of where I just match any rectangle. If I were to move this above this one here, hopefully this doesn't break Visual Studio. Whew, that was close. Every time I see that little thing come up, say, I'm working on something, I'm just, whoa, this is going to be crazy. So this here is going to say that, well, this case will never be reached, because you're catching all the rectangles, right? So that's a few nice additions. And then, of course, how do you do a default for this? What if there's other types of shapes in my application? Well, you can say you have a default pattern. We have this underscore. Just as with this thing here at the top, where I say I don't care, the underscore I don't care, pretty much is short for I don't care, then we do the same thing here at the bottom. For anything else, just catch all of these different things. So this is pretty cool. So this here means that we can do all kinds of crazy things. Now imagine if you have expression-bodied members, which is a way for us to introduce a syntax like this here, right? So I could do this instead. Now I can say I have this explain shape thing, and I don't need to have the curly braces and the other things, right? How would you do this previously when you have the if it's type off, and then you cast it, and then you check the different values? That syntax gets really nasty. But in this case here, when you use a switch expression, you can use this with expression-bodied members. And in all honesty, we're just saving these characters plus the curly brace at the bottom. But someone wise said that it's all about saving characters because we don't have too many characters to write in our entire life. So we just make the C# team write them for us. All right, so we have some other ways to do this as well. This here, if we run this, it'll, of course, work. In this case here, it's going to say that these different sides are not equal. It's going to say A is not equal to B because we passed this triangle where the sides are different. And then we can run this against other patterns as well. Another example of this is a tuple pattern. Now imagine the case where this example actually comes from the C# blog where they talk about these features. And I think it's a really good explanation of how to do tuple patterns. So imagine we call this method called open the door or open door. We send the current state of the door, which in this case is locked. We want to open the door, and the final parameter here indicates that we have a valid key to open the door. Kind of makes sense, right? So there are multiple different ways for us to build this state machine or this logic in our applications. But with expressions and with switch expressions, this here gets pretty nice, especially with the tuple patterns. So in this case here, I create this tuple with values. So we switch based off on these three different values. So this is, look at this as a tuple, right? And then we have more tuples in here which need to match those particular values. So we can say when the state is opened and you want to close and you don't have a key, well, you can close the door. You don't need the key for that. And then of course, there are different cases for when you don't have a key and you try to lock it, or you try to open the door, it's locked, and you don't have the key, and so forth. So you can build all of these really amazing things using the pattern matching and switch expressions. And then, of course, if you try to close the door when it's not closed, or when you try to close the door and it already is closed, it'll throw an exception. So you don't have to return everything from these different things. So this expression here allows you to return which state the door will be in once you've performed your operation. Doing this with traditional approaches is a lot more chatty. There's a lot more code to it. Now, of course, you shouldn't take this to the extreme extent. I've seen people kind of replacing all the if and else statements with this. So imagine this case where we have, I want to take a Boolean and get the visibility out of that. So let's say that we work in WPF or in Xamarin. I want to change the visibility of an element based off a Boolean. So in this case here, we simply say, well, we're going to switch based on the current state, which is the Boolean. And then for true, it's going to return visible, and for false, it's going to return hidden, even if it's null, because we all know that you have 3 states on a Boolean. It's going to blink. So don't do this. This is a really bad approach to do it. Don't replace all your if and else blocks with switches and pattern matching, because it doesn't really make any sense. Now, finally, there's one more interesting approach to this. So a more real-world scenario as well, as opposed to the explain shape example. You might have this idea of, well, I want to grab something from the web. So we have this example where, I'm going to show you the code here. We get a shape from a web response. So let's say that we call an API. This needs to be converted into something. It's going to give us an HTTP response message, and this method is going to be asynchronous. Now, of course, we can use the switch expression for this as well. So we could say here that this is an asynchronous method. It returns a shape when it's done, when all the asynchronous operation is done. We use this switch or this switch expression syntax to say when the message has a status code of these different values, then run these different things. So when it's at 200 OK, we can extract the shape from the message. If it's not modified, we might have a cache where we load this thing from. And then if it's a bad request, forbidden, or other types of exceptions, or other types of status codes, we just throw different exceptions. Of course, you can solve this with a normal switch and case syntax as well. But then you get more, like every case, you need to have a break or a return, and so forth. This is just a little bit less chatty in your application. Makes it a little bit more nice to read and probably a little bit more hard to work with. All right, so that's recursive patterns. Next up is a feature called ranges. Now, this is the thing that broke when I updated Visual Studio. So what's interesting, though, is that I can code everything in Visual Studio and I can run it from command line. So I'll do that. Two things that we have in here, it's features introduced in earlier versions of C#. We have this span of t. It's a way for us to reference a chunk of memory and then work on this chunk of memory without copying this array or copying the sequence of data. So imagine that I have this huge array of numbers or strings, and I want to say I want to get the middle ones. You don't have to copy the middle ones into a new array. You can just simply point to the start and finish element, and you get a new array out of that, or a new reference to that particular part of memory. So they did a lot of this in, I believe, in ASP.NET Core, and just improved performance a lot. So ranges is a way for us to express how we want to grab this piece of data. So you see the squiggles here, it's telling me that you don't have the things you need in Visual Studio to run this, but I know I do. But there's some mismatch between Visual Studio and the runtime, or the compiler. So what I'm saying here is that I want you to start off from the fifth element, and then give me everything one from the end. So start off with number 5, index 5, which is number 6, and then give me everything until one from the end. So this should give us 6 through 9. And then, of course, this gives us a reference to that particular part of memory, and we can run a for each on that because it's a line numeral. So if we run this, it should, the first section here in this example should say 6, 7, 8, 9, which you can see here at the top, hopefully. Then next up, we have another example of this, where we don't do a slice. We simply say, I want to use the normal array syntax and pass this range in as a, not as an index. You can do multiple different things here now. So you can say, I want to get either an index. An index is a reference to a particular item as well using this kind of syntax. Then you can pass an int index, which is normal, just an integer. And then you can pass the range that gives you a new span of the type that you're working with. So this here will, of course, give us 1 through 4. But it's a little bit more compact than the first example. Then, of course, we can use this index syntax as well to say, just give me the index. This will give us the index to the fifth element from the end. And then it can be really confusing to specify 2 indexes, if I can just expand this here. You can say that I want to start off from 4 from the end and go to 2 from the end. I don't know why you want to do this, but this just shows a way for you to express that. So you have 2 indexes, and then you can use that together with this range syntax. Like you have 2 different variables and use that with the range syntax. And if we run this, it should give us, you can see that 7 and 8. So it's starting off at 4 from the end and then give us 2 elements from that. We could, of course, also say just give us some more elements. Or give us everything until the end, right? So we could do different ways of us to expressing this using ranges. And this is something that's been around for a long time if you work with Python or other types of programming languages. So those 2 are pretty much coming into C#8 because they're in this release candidate as previews. Now next up is one of the probably the most sought after feature in the language is null reference types. So the idea behind null reference types is that when they started off building C#, they made one huge mistake, and that was introducing nulls in the language. It's really hard to remove nulls now. So a way for us to solve this problem is to make it easier for us to know when there's potential null reference exceptions or null reference problems. So imagine that we simply now say I can change something in my configuration of this project and say I want to enable nullable context. What this does is that it then interprets everything as non-nullable. It's not going to break the application. It'll simply give you warnings. When you look at you can get hints that, well, you should probably do something about this. So in this case here, I'm saying, well, string in this case can be null, and that's totally fine. My application handles the cases where the name is not initialized. But what if I say that this here shouldn't be null? Well, then we get some squiggles here on the constructor to tell us that you should probably initialize name because you require that in your application. This here is just a hint for the time being, but imagine being able to turn this into compiler warnings or into breaking things in your compiler, right? It breaks the build. That would be great, because this here is going to tell us that, well, you have a potential problem. And of course, if you were really good, you would then change name as well, so you cannot change it externally. If you introduce a constructor parameter for it, you would make it immutable and so forth. But that kind of requires a huge effort in most applications. It's easier for us to simply just remove it and see where it kind of breaks. Because what this does now is that it doesn't give us any problems inside our person class. But where it does cause interesting implications is if we look at where we use this. So imagine that we use this in this method called insert or update. We can say, I have this person here, and I'm trying to access name here, but it's going to tell us that, well, there's a possibility that you're going to get a null reference exception. So it's going to start telling us inside our applications or inside our code here that you have potential issues. You should probably solve that. I have two ways that I can solve this right off the bat here. If I know that this is not going to be a problem, or if I'm worried that this is going to be a problem, I can simply say, well, don't get the length if this is null. Or I can say that I promise that this thing here is not going to be null and just go ahead and give me the length anyways. If you do this, you're going to get into trouble. Not by me, you're going to get into trouble by the compiler. The same goes for the parameter that we have here. We can say here that this would potentially be null, which then tells us that, well, you should probably do something about that, because person here shouldn't be null, so in case person is null, we don't get the name and then we don't get the length. But then you can also say, well, I really want to get the name. And this here starts to get pretty nasty. I don't particularly like all the bangs in the code. But you can do this if you really want to. Now, an interesting take on this is, what happens if we say that this here is non-nullable, and we pass, actually we do this, we'll pass null into the method. That's probably not a good idea, right? So passing null in here now is a potential problem. But I know that I can promise that null's not going to be null. The problem goes away. That's awesome. I don't know if this is going to make it into the final version, but we'll see. All right, so. And then we have something else in here which is interesting. We have this null coalescing assignment. So instead of me having to say person is equal to person, and if it's null, you initialize that, I can say, if person is null, just create a new person for it. I like the syntax, but it can get pretty confusing. Because what happens if you kind of remove that, you can have a problem. It's easier to make this a problem rather than the old syntax. This is just easier to misunderstand. Anyway, so I think this is a great addition to the language. And John Skeet has a great blog post on how he did this in Noda time, where he just introduced these nullable types, nullable reference types, and just found a lot of potential issues. I think someone made a calculation of how much money has been lost due to null reference exceptions, and that's a lot. Question? So your question is if the maybe pattern came out of this, so that if it's null, you do something, and then if it's not null, you do something else? Yeah, for sure. So you have multiple different ways to solve this, right? So you can either you just handle it like you normally do, that you create a new object if it's null, but we want to get into a place where we don't have any nulls at all in the language, pretty much. But that's going to take a lot of effort and a lot of time. The next feature is using declarations. This is simply a way for us to not have to write color braces. Again, it's about saving characters. So look at this example here. I don't have using around my HTTP client. I'm simply saying, create this HTTP client. As soon as this context that it's used in is completed, go ahead and dispose of that. So this means that when we reach this here, it'll dispose that. It's a nice addition. Again, saving characters and just making the code a little bit more readable. Because it doesn't make sense to, I guess it makes a lot more sense because a lot of cases you want to do this. All right, then we have another preview feature. Now when I install the release candidate, this feature took a little while to get going because you had to change the compiler to look at the preview features in C#8. So you have C#8 and then you have C#8 preview features. They're apparently different. So in this case here, I'm creating this application inside my application. I call something called compute here, which then runs some over-engineered method to compute something. I like to over-engineer my solutions. No, I really don't. But in this case, I like to do it. Because what I'm trying to do here is I'm just concatenating the integers, or I'm just adding the ints together to get the length of something or a value out of something. But the problem with local functions is that they can capture the context. They can change things in your class. So if we remove this static from here, which is what's introduced in C#8, we have this local function that's now capturing the context outside of it. It captures the class, the instance, and it captures everything that it has access to in the method. So we can go ahead and change the name, which is a property in our class, and we can go ahead and change this value, or reuse the value, inside the method. Now, in order for us to speed up the performance a little bit, we can introduce the static keyword. This introduces a way for us to not only increase the performance, but also it promises that there's no side effects. Now, local functions have their use case. Some cases you can just break them out into external functions, but in a lot of cases it might be nice to just have them in this nested context as well. It's a nice thing if you tend to use local functions. The final feature that I can show you in Visual Studio, there's a ton more features that we're going to talk about, but I have to use PowerPoint slides for that, unfortunately, because they haven't made them into the language yet, and honestly, I didn't have time to build them myself, because I don't know how to code a lot more. I just know how to show all of these cool things. Again, joking aside, in this example here, we have something called asynchronous stream. So a lot of the times, you might want to work with data that's streamed into your application. Imagine that you're reading a file from disk, you're reading something from memory, you're talking to a website. You get bytes and chunks at a time, right? It downloads the data as it goes. So wouldn't it be very nice for us to be able to say, await for each item that we're getting out of this enumerable? Now, we can of course say await in front of get here, but what that does is waiting for the entire thing to complete. What this new syntax, where we put the await keyword in front of the for each, says is that each item is going to be brought to you asynchronously. So if we have a look inside, actually let's run it first and just see what the output is like. Hopefully this feature works. This here is going to stream out the numbers to the console. So as we get them into the application, it'll use a console write line to print out the data into the console. So get here allows us to do a few different things. First of all, we mark this as async, like we do with any type of asynchronous methods. Then we use something new called an iAsync enumerable, which is going to return a string one for each item. So each item is going to be an integer. And then I simply have a for loop. That for each item is going to return a value. But each value is only brought to you after 300 milliseconds, because we are just delaying for 300 milliseconds here, and then this thing here returns the value. A less confusing piece of code would be to look at how do we do this for if we're loading something from the disk. So I have something here that loads some lyrics from a file. So again, I'm using this using declaration here just to make sure that I can use my entire stream inside my method here. And then, side note again, this thing here, I don't think this particularly looks nice. And an addition to C# sometime in the future is to be able to do this in one line like this. So you can get rid of that. That's also a nice addition. Anyways, it doesn't work now. So what this is doing here is that it's loading each line asynchronously. Let me just scroll it up. And then it's going to return the line, and then just to simulate that this is going to be loaded from the web or something, or that I have a really slow mechanical disk, it'll delay for 400 milliseconds. So this means that it's going to load a line from my file, and for each line that we're going to get, it'll do something with that line. It'll return that to whoever calls this method, as long as they're using this await for each syntax. So if we run this, the syntax for this is very similar. So again, we were saying await for each item or for each line that we're getting out of lyrics, get lyrics. So now if we run this, you can guess the song. Rick rolled. All right. So this just shows you that you can now use these asynchronous streams to get data in an asynchronous manner. So you don't have to wait for the entire chunk of code to be completed. And prior to this feature being added to the language, I've had situations where I've tried to write the syntax without knowing that this is coming in C#8, but it just doesn't work. Like when you do this, you try to yield return something from an asynchronous context, and it just doesn't work because there's no support for it in the language. But now with C#8, it is supported. So I think this is pretty great features, and this is what we can try now in Visual Studio 2019, except for the ranges. But that might just be something local on my machine. All right, so let's go back into PowerPoint. And I have a huge chunk of features, or a lot of features, that are potentially getting into C#8 or C#10, or who knows which version of the language they're going to get into. One of the things they're looking at, and you'll see I have links at the bottom of each slide to the particular language features of the discussions on GitHub, and I'll share these slides later on my Twitter, so you can go ahead and check these out if you want to. Now, one of the things they want to add is this thing called target type new exception. So again, saving characters, we no longer have to write var triangle is equal to new triangle. Instead, we say triangle is equal to new. So we save 3 characters. That's great. Although in situations where we have this dictionary here, we have a dictionary where the key is a string, and then we have a list of integers as the values, we can simply say new here, and that'll just create that entire thing. So the amount of characters that we saved, or the amount of code that we don't have to write, is starting to expand, right? And then the same goes for this internal thing here. We can say that just create a new thing for what the dictionary expects. And I do believe they had to modify the runtime to make this work, because there's no support for doing this. I'm not entirely sure. But again, this is actually a feature that one of the community members helped out building into the language. And then just a small feature. If we work in deconstruction, what we had to do earlier was, in order for us to create the default values for these 2 things in this deconstruction, we'd have to do this. But why not just be able to say that, give us the default of this, and the compiler just figures it out. Just making the code a little bit more readable and more maintainable, I guess. Now, how many of you have tried to have done your own custom attributes and wanted them to be generic? 1, 2, 3, a few of you. If you do ASP.NET, I've had many situations where I wanted to do this. So in C#8, they're introducing generic attributes. So previously, you had to do your custom attribute and pass the type into the constructor, and the code just got a little bit nasty. We don't want to do this anymore, but instead what we want to say is give us just a custom attribute of T, or you can just introduce this generic constraint on your type. I think this is a good addition. This is probably something that's going to be very useful. Next up is something called color expression attribute. Imagine we have this function lives inside the debug class. So we have debug.assert, which takes a condition, which is if you say my name is equal to Filip, or array is not equal to null, or array.length is equal to 1, or so forth. You have a condition that you need to assert on. Now, the second parameter is the message that you want to pass that's going to tell you if this assertion did fail or not. What this color argument expression is doing is kind of pointing to the same thing here, right? So it's pointing to the condition. So that means that we no longer have to specify this manually. What's going to happen here is this thing here is going to be compiled down to something looking like this. So it'll just take the entire expression and put that inside a string. So this attribute here just figures this out for you. This is a great addition, especially if you're doing logging, or we're building a logging framework, right? So you don't have to pass that message yourself, and somehow it just figures this out. Now, imagine if you worked in programming languages like Go. There's this really interesting feature that allows you to pass any type into a method that expects something that looks like the type. It doesn't have to implement the interface. It doesn't have to be the exact same class. It just needs to share the same traits as that particular type. So what they're doing with usings is that they're doing a pattern-based approach to this. So in this case here, our class has a dispose method, which means that I don't have to implement iDisposable to be able to use this inside my using block. Now in programming languages languages like Go, they take this one step further. And I hope that they're going to do this in C# as well. So imagine the case where you can pass anything into a method that expects an interface. An interface should just tell you which type of methods you should have on your class. It shouldn't be a requirement that your class implement the interface as long as it has the same methods and the same signatures. I think it would be a great addition to the language to just allow you to pass anything into a method that expects the interface. Right? Not everyone probably agrees with that, but I think it would be a good addition to the language. Now, one feature that I don't think that I particularly like, I'm not convinced that this is a great addition to the language. It's default interface methods. So this means that we can now introduce methods that have a body on our interfaces, or an implementation on our interfaces. So our interfaces is now taking a different turn and allowing us to provide logic inside the interfaces. And I don't think that makes a lot of sense. So in this case here, we have this authentication interface. In version 1, the person that built this thing just introduced a normal synchronous version of authenticating the user. And we implement this in our application, and everything is well. And then someone decides to, well, I want to update the interface. Now what happens is I pull this into my project, and I get compiler errors, because it no longer compiles, because you're not implementing the members. But what I'm doing here is I'm providing a default implementation for this. Now this here is, of course, this here is good. This here works, and will allow us to just compile the application and run the code. So imagine that we have the same application, we update our NuGet package, we get this new thing, we don't implement anything in our application, we can then still call authenticate async, and it'll give us a null user. So, this here is a valid case for it. But I can put whatever I want in here. Like I can put a lot of really nasty logic in here. This here starts to turn into multiple inheritance. Because if you have multiple different interfaces having multiple different implementations of things, you can just pull in implementations from a lot of different places. Now, compared to multiple inheritance, you don't have the instance or this diamond problem that you would in C++, but it's still a way, it's still not the best thing ever, I guess. I'm not particularly sold on this, but I know that a lot of people that provide packages on NuGet and provide libraries out there really love this feature because they get a lot of hate back when they break applications.
Which you do get that problem. If you have the same base class doing requests, you have to specify which one of them you are using.
So you're saying you still do get the diamond problem? Oh, that's interesting. Okay. So this is like multiple inheritance.
It is.
It is. All right, so I definitely don't like this feature. Then again, it's probably the people that provide you with these packages, if you do libraries and stuff, they like this because they don't get a lot of hate back when they break your applications, because they can just add things instead of just requiring you to implement all their new things. Then again, they could just introduce a new interface. I don't know what the problem is with that. All right, so that's an interesting feature being added to the language. We'll see if it gets into C# 8 or 9 or 10 or whichever whichever language version it gets into. Now, we talked about the null call async assignment. I like the one at the top here. This is a normal traditional syntax that we do. You can also be a bit more expressive to say if x is not equal to null, just introduce a y variable into x. But now you can say x question mark is equal to y. I guess sometimes it's a little bit better to save up on characters, but this is a little bit more, explains it a little bit more. Especially if you have developers that worked in different languages but are new to C#, this thing here might be very confusing. And that's also something you have to struggle with when getting people into your teams, right? We're also getting things like, I talked about the switch expressions, relaxed ordering of ref and partial modifiers, alternative interpolated verbatim strings, stack allocation nested context. These are just features that, I don't know, not worth showing off. They're just very edge case features that not a lot of us will use. So with that being said, that's C# 8, right? So what's happening after C# 8? What can we expect coming in the next version after the one that we have now? Well, to be honest, we can't really expect that we're getting any of these features in C# 8 either. Because when they're going to drop C# 8, they might pull back features, and they've done that in the past. So we just have to be very glad if we do get a lot of features in the language. Hopefully, they're going to skip 9 and just call it C# X, because I think that would be a much better naming for the language. It probably shows you that I've done more marketing than programming for the past years, right? Okay, so what's going to come in the next version of C#? And again, don't be sad if they cut the features and they don't make the cut into the language. I've been bitten by this a few times before. I'm really excited about a language feature getting into, for instance, C#6 record types, and this just didn't make it into the language. And I've been pumped and getting people really excited about the features, and then they just don't make it into the language. So one of the features that they're looking at, and these are all suggestions from GitHub. So I took all the champions and the different things they're talking about adding to the language. We can do this today. We can have this negated condition if statement where we say, well, if shape is not a triangle, or shape if not shape is a triangle, this here doesn't really read very well. So what about we change this up and say if shape is not a triangle? That's nice. Or if not shape is a triangle, I don't like that. Or introducing a new keyword and say unless shape is a triangle. I don't like that either. I'm not trying to convince you which one is best, but this one is. Because we already have the keywords. We already have it's not in the language, right? Introducing one more keyword for just one purpose doesn't make a lot of sense in this case. Anyways. And then we might get some updates to the way that we can work with null. So we get this way of if it's null, we just return, and then if it's not null, we can await the task for null conditional awaits. How about we simply have syntax for saying, well, if bang task, or await bang task, this here would then just await this if it's not null. This is an old suggestion, so this here is probably going to change to, I don't know, question mark, double bang, underscore, who knows. Something else. The bang here says it promises that it shouldn't be null in other cases. So this here should say, await this, I promise the task is not going to be null, so maybe it should be question mark. And then, of course, we have record types. Record types has been one of those things I mentioned. I hope to get this into C#6. When they started writing the C# compilers, this was one of the features they talked about introducing, especially since it made it a lot easier to introduce features with the Roslyn project. So record types is a way for us to kind of make this a little bit better, as well as making the code that we write a little bit shorter. So in this case here, I can convert my triangle of shape with all these different properties in the constructor into this thing here that I call a record. That's really good. So what benefits do we get out of this? Well, it introduces a whole lot of things under the hood. Imagine the case, I have this simple one-liner that says what I had here at the other slide, and then it just introduces the constructor. It makes everything immutable because you can't change A, B, and C. We get true equality checks where you can check the values against each other. It doesn't have to check just a reference. We get things like the width method, which allows us to work with this in a true immutable manner. So you can say, I want to get a new version of my triangle as a totally new object, but with a little bit changed value. And of course, then we get the deconstruct, so you can use this with pattern matching. Now, the reason that this hasn't made it to the language is because it's really hard to implement. Getting this implemented is easy, but making it work for inheritance is really hard. Because if you have two immutable objects and you inherit from one of them, it's going to cause really interesting side effects. So I would suggest just don't allow inheritance for record types, but they just want to make it perfect for all the different cases. So this might make it into a future version of C#, hopefully. And then declaration expressions, I mentioned this. I would like to change the way that we can initialize that character or the line of text that we saw in the demo that we had. So we just move this into the context instead. Just makes the code flow a little bit better. And of course, why not make an update to dictionaries as well? This here is a way for us to do a collection initializer on dictionaries. But what about if we make this look more like Python? That would be great. Yeah, that looks really good, right? So if you like these things, you should go onto GitHub and just +1, and hopefully someone's going to build them. I don't think everyone's loving this feature, but I think it's a great addition. Just makes the code more readable and a little bit more nice. All right, so a few more features that I don't have code for. Type classes is one of the features that we might be getting into the language. The reason I don't have a slide for it is because I'm not smart enough to explain it. Simple as that. And then read-only struct members, params of span of t. Now I don't understand. So span of t is a sequence of, it's an array, right? It's a sequence of bytes. So how would params of span of t work? I don't know how that would, it would just be a longer array, right? And then we might get and is equal, and or is equal assignment operators, just like the null equalizing assignment where you say question mark equals. This here would somehow figure out a condition and just set your variable based on something. I don't know how that would work, but they're looking into adding these things as well. So with all that being said, like in C# 1 through 7.3, we got all these really interesting features, and especially past C# 6, we've seen a huge amount of features being added due to the fact that they introduced the Roslyn project. You know, we have improvements to async and await, and we even have the async and await capabilities, which are now also making it into languages like JavaScript. So not only is the C# team looking at other languages like Kotlin and Swift and Java and JavaScript, but they're also helping other programming languages becoming better by introducing things that are working really well in C#. Question?
These proposals that you've talked about, are they proposals where a member of the C# language team has said, that sounds like a good idea, or given some kind of response?
So your question is, the proposals that I've talked about, are they endorsed by the C# language team? So that's a very good question, and what happens is that you can put up one of these suggestions or an issue on the Roslyn project, and what happens is it goes through language design meetings, and they talk about them internally as well. So if a lot of people from the community really wants a language feature, they're going to vote on it, and then it goes through a process of where they internally talk about how would this work in the compiler, and then it translates into one of these champions. I think that's the work process that they're using. So it is people internally on Microsoft that work together with the community and the C# specification team to make sure that they don't introduce things that shouldn't be in the language.
These were all champions then?
Yeah, they're all champions. So you're asking if all the things that I've talked about is champions? Yes, they're all on the champions list. There might be one or two that have been from other places as well, or on the Roslyn repository where they also talk about features. But there's nothing in here that's from a community member that's not on the Roslyn or C# language repository where it's been talked about internally. So we got all of these features prior to C# 8, and with C# 8 we get pretty much even more features. We get kind of the same amount of really amazing additions to the language. And I think it's a really interesting time to see that C# takes shape from other languages and takes shape of how we build applications now versus how we build applications 20 years ago. It's a huge difference how we work with the web, how we work with databases and all of that. And the language evolves into that with async and await and with things like record types, which is really good for when you're generating code and so forth. So I think my favorite feature being added now to C# 8 is the pattern matching improvements and the way that you do switch expressions. Having worked a lot with Kotlin recently, I've found that it just makes the application a lot more readable. The code is a lot easier to work with if you don't make it hard on yourself and do things like I did with the Boolean, right?
Does it feel more like functional programming?
So you're asking if it feels more like functional programming. I haven't done much of functional programming, so I couldn't say, but maybe someone from an F# experience. No.
Either did I, because it works out and we talk a lot about functional programming. It seems like that.
Yeah, so you're saying that it seems like C# is taking the approach of being more functional. And that's a very good point, and over the years that's been the case as well. They've taken things from imperative, functional, and declarative programming languages. That's why language integrated query made it into C# as well. So they took SQL into C#, right? And now they're taking F# stuff into the language as well, just making it work for anyone. And although I like writing the switch expressions and more functional approaches, you can still use the traditional approaches and don't use that. So a problem with this is that we'll have a lot of different permutations of the same type of applications. The code will look very much different than what it could do in the past. All right, so that's all of the features in C# 1 through 8, pretty much. So it's been a real pleasure being here. If you have any questions after the talk, just ping me on Twitter, come up here and talk to me. I'll be around the conference, and hopefully I'll see you next year as well. And don't forget to vote on your way out. Ah, you've got a question. So you're saying that some of the features that require you to get things into .NET, the framework or .NET Core, will make it into Core, but not the full framework. Yeah, I've heard that from so yes, I think it's true. I couldn't swear on it, but things like ranges will probably be across the framework as well as .NET Core. It really depends on if it's a runtime change or if it's a change as in how you use things in the framework. So if it's a runtime change they need to make, like this new thing that I talked about, if they need to do a change in the runtime, that's probably only going to happen in .NET Core. But I couldn't promise you on that, so you'd have to look out for that. All right. Thank you so much for coming. Don't forget to vote on your way out.